Let's now talk about physical properties of alcohol. Because of the presence of their OH groups, alcohols share some of the properties of water, and water is rather unique in its physical properties. So I think it's worthwhile now talking about physical properties of alcohols themselves. When we talk about shorter alcohol chains between C1 and C12, they're liquids, while the higher ones, the C13 and so on, are sort of oily solids, more or less. All alcohols have light and fairly pleasant smell. And the unusual thing here is that C1 is already a liquid. If we talk about alkenes or alkynes or alkanes, all the way up to C4, we still have gases, and only then we start having. So methanol seems to be a little bit of an anomaly, and because it has a high boiling point. This high boiling point is caused by either hydrogen bonding or dipole-dipole effect. Methanol is a relatively polar compound. This is a dipole moment here and dipole moment here. And also the two free electron pairs have their own dipole moment. So overall, methanol has a quite sizable dipole moment of about 1.55 dBs, which is much more polar than hydrocarbons. On the other hand, hydrogen bonding is a strong contributor as well, and not just to methanol, but to most of the other alcohols as well. This is how hydrogen bonding looks like. It is established in a relatively linear fashion between oxygen, hydrogen, and a free electron pair on the other oxygen. And we were asked to determine, well, which one is more important? Is it hydrogen bonding or dipole-dipole effect? We need to make a fair comparison in order to determine that. And the fair comparison would be to go from propane, which has neither dipole effect nor hydrogen bonding. This has a very low dipole of 0.08. Boiling point is minus 42 degrees centigrade. And then move first to dimethyl ether, which is similar in molecular shape to propane, but is not able to hydrogen bond just like propane. However, it is more polar compound. It has a dipole of 1.3 dBs, and the boiling point does increase to about minus 25 degrees. But as we now move from dimethyl ether to ethanol, a molecule with same molecular mass, the polarity doesn't really change all that much. The dipole here is about 1.69 dipole, so it's still a fairly polar compound. But what it does change is now ethanol is able to hydrogen bond. And despite the modest change in polarity, the boiling point just soars to 78 degrees centigrade, so by more than 100 degrees, which clearly indicates that hydrogen bonding is the main contributor to the high boiling point of alkanes, and it's not just increasing their polarity. Many alcohols are soluble in water as well, but this effect depends on two conflicting factors. One of them is that alcohols are organic compounds, so they have a hydrocarbon chain of certain length, and this hydrocarbon chain will be hydrophobic part of the molecule, which will decrease the solubility in water. On the other hand, there are the free electron pairs here and a hydrogen which are able to hydrogen bond to water, for example in this information. And this hydrophilic part will increase the solubility of alcohols in water. And it's really the balance of these two effects that determines whether a specific alcohol will be soluble in water or not. For C4 and higher, if we have a linear chain, the alcohol is not soluble in water. So hydrophobic part wins. But for C1 to C3, regardless of the shape, alcohols are soluble in water. And furthermore, if we have branched alcohol, then they tend to be more soluble in water because their contact surface is decreased with water. So even though their hydrophobic part is still there, it contacts the water less. So it is a little better product.